Okay, I am a retired experimental physicist. That's all I have done my whole life. I'm a professional physicist. I've never done any politics or anything. My now deceased wife was an accountant, a certified public accountant, and taught me a little bit about how to do an audit. And so what I am doing here is what you would call a scientific audit. And I'm exposing fraudulent behavior in the scientific community. This is not easy to do, but somebody's got to do it. I'm the fall guy. Okay, as we all know, the IPCC and its collaborators and contributors all forecast an impending climate crisis with catastrophic consequences to the world population. They predict an alarming increase in the frequency of dangerous weather events and other terribly bad stuff. So this work gives you a scientific audit of those results, and you can call it, if you wish, a whistleblower report. I'm naming the names and showing where they did it. And the IPCC and the contributors have done amounts to fraudulent bad science. Okay, one of the first things it does, it exposes a subtle but very critical flaw in the design of the two workhorse satellites, the Terra and Aqua satellites, put up by NASA. They were effectively blind to an important part of the outgoing light, reflected sunlight, the specular reflected component of it. After a decade of observation, they found a totally ridiculous result. This is definitely an aw shit moment. What do we do now? The results are ridiculous. We can't report them. How do we cover them up? To cover up the flaw, what they ended up doing is overwriting all of the data in the public database with a second seriously flawed study using very flawed experimental scientific methods from so-called ocean heat content, which is really just masquerading as ocean temperature measurements. I will be exposing those, the data. What they did was they simply fudged the data. And I'll show you how and where and give you all the various methods that they use for doing that. Okay, and for backup, for the fact checkers, this is all, I'm just going to show their published diagrams where the arithmetic doesn't work. So the conclusion is global warming and climate change have not been proven. There's no proven climate crisis. The world is wasting trillions of dollars trying to limit the extraction and use of fossil fuels. If it ain't broke, don't fix it. If it ain't proven broke, don't fix it. Okay, so they start with a very plausible scenario, a model that starts with a highly plausible causal linked chain. So they start with the extraction and consumption of fossil fuels. That leads, or may not lead to increasing atmospheric CO2. The Keeling curve, as we have seen repeatedly shown here, is probably the only piece of good science. Yes, CO2 in the atmosphere is rising. Whether or not, okay. So that their argument then is that leads to a positive energy imbalance. Spend a lot of time on that. In turn, that leads to global warming. In turn, that leads to climate change. In turn, that leads to predicted increasing frequency of weather events. That predicts then this apocalyptic climate crisis. So any one link in this chain is broken, the whole chain collapses. As I mentioned, the Keeling curve, as we've seen for CO2 increase, is probably the only good science. It may or may not be related to anthropogenic use of fossil fuels. It doesn't really matter because all of the other links in the chain are broken. I will show you how to break the other links. The last link in the chain is the easiest to disprove. That was the data there, and that was also dishonest science. I'll go through that. The important piece of work there was shown in a Physics Today article predicting and managing extreme weather events. And they say the Earth's climate is warming. And the authors were Jane Lubchenco and Thomas Karl. Jane Lubchenco was an undersecretary of commerce in charge of climate. So if these guys couldn't get the world's very best data on climate, on what's been happening for the world's weather, I don't know who else can. Okay, so what they did was they created a climate weather index, an extreme weather event index, and they plotted it on a diagram for 100 years worth of data. And it was some numerical composite of heat waves, cold spells, droughts, floods, landfalling hurricanes. They left out EF3 plus tornadoes because, as Steve Koonin points out in his book, those were actually decreasing all this whole period. So I will assert that their own data disproves their own assertion. Okay, I've taken that bar graph that you saw and replotted it twice. I just simply laid a transparency on it, converted a bar graph to a bunch of dots. I did that twice, and then I flipped one of them 180 degrees left to right, so that now one of them is misplotted with time increasing to the left, and the other is plotted. Now, I will assert, common sense, if you can't tell which one has this extreme increase in the last 3 decades, then, and if you're not willing to wager with very good odds, trillions of dollars, then it is not obvious that extreme weather events are increasing. Okay, before I continue, we need to clarify a few important points. What is needed to scientifically define? In order to address something, you need a careful scientific definition. So what is the careful scientific definition of global warming? And that has changed. It has now been switched to Earth's energy imbalance. The acronym, the EEI, has only been recently added. So let me break down the question. Why is energy imbalance now the metric? And so let me break that down further into the question, what is wrong with using global temperatures? This is something Jonathan Kohler talked about yesterday. And what is wrong with just using anomalies? Okay, global warming suggests the global average temperature is rising everywhere. Unfortunately, that's very, very difficult to define. Once you define, it's even harder to actually measure. Whatever metric you use needs to be something you can measure. I'm a measurement freak, as you can tell. If it hasn't been measured, I'm not going to believe it. Okay, to measure the global average temperature, that means you need to measure the whole globe. Okay, and there's what are called the Shannon and Nyquist sampling theorems that says you need to measure everywhere on the globe in order to define this. Okay, so you need to cover the globe with a grid with a set of grid points the order of about a kilometer apart. So there are 510 million square kilometers of the surface area of the Earth. You need 510 million recording thermometers. They clearly don't exist and wouldn't fit any budget. Okay, unfortunately, okay, here, this is an earlier map that Willie Soon sent to me. Okay, and this shows where all the temperature measurements are. There certainly are 500 million of them. And you'll notice almost all of them are on land. But land is only 29% of the Earth, about a quarter of the Earth. So where are the ocean measurements? Okay, oceans are 71%. And we have virtually of the actual measurement stations, totally vanishing number on the ocean. Okay, in addition to measuring on this grid, you need to measure, there's also a temporal dependence. And you need to measure pretty much once every hour. The three biggest obvious temporal variations in temperature are just simply the day-night cycle. Nights are colder than days. The seasonal cycles, the weather. Okay, these are all on daily, weekly, annual cycles. So you need to measure all these 510 million points once every hour. Also impossible. So it's not that it's impossible to define. Yes, I just defined it, as Jonathan Kohler pointed out, was claiming, but it's impossible to measure once defined. Okay, the other thing that has moved, and virtually every speaker so far who have preceded me when showing a climate metric has presented an anomaly. What is an anomaly? It's and what is wrong with the use of anomalies? I assert that this is all bad science. Anomaly is a change over time with respect to some previously measured reference value. So what is the zero? What does anomaly equals zero really mean? It is some offset from some reference value. Unfortunately, no one ever tells you what the reference value was. Okay. No one tells you how it was measured, where it was measured, what altitude, what location, what averaging areas were used. So what this also points out is that there was no standardized method of measuring this. So one guy's anomaly will be very different from another guy's anomaly. It also doesn't specify the altitude of where this measurement was made. Whether is it at the top of the atmosphere, the bottom of the atmosphere, nobody ever tells you. And that tells you how it was measured. Like I say, I need to know how it was measured in order to believe it. Okay, frequently these are misused with no reference value ever given. And worse yet, if you have if it's useless for the reader, it's also useless to a subsequent investor. As Roland Connolly was showing, well, if you have one set of data and then you want to link it to another set of data, you need to, and they're both anomalies, and each guy used a different reference value. There's no way you can link the two plots together. This, we will find, was a very serious problem in the reporting of the ocean heat content data by Lyman et al. In 2010. Most authors just say, well, we subtracted off the mean value, or some say, well, we subtracted off the initial value. You never know. Does everybody subtract the same value? They never tell you. So poor recording and reporting of these subtracted has some very serious consequences. Show you this, that in the Lyman et al. 2010, Lyman and Johnson 2008 for the measurement of the ocean heat content. So these guys are even worse. They claim to infer critically important meaning to the difference between the associated data subtracted offsets of sequentially acquired XBT and Argo data. We'll get to that in a minute. Okay, so, it's also useless. You can't, if you don't know the real value, you can't even use it for calculations like how much heat is radiated and where is it radiated from. So there's no way to check any of this. Okay, so because of all these flaws, it was in fact, in response to criticism that I expect, was recognized that this is bad science and we need a better metric. Okay, so what is the better metric? Well, the Paris Climate Agreement still constrains predicted temperature anomaly. And that assumes that the prediction is assumes that the prediction is accurate. You don't even know that to be true. They replaced, fortunately, with what's called the Earth's energy imbalance. And I'll show you why they did that. It's an actual value. It's not an anomaly. So now you can audit it. Okay, and this was recently confirmed. Secretary General Gutierrez declared a few weeks ago, declared a climate emergency, citing that the Earth's energy imbalance, which the gap between absorbed and released heat, has hit a record high. So even Gutierrez now accepts this is the correct metric. Okay. Given it's much easier and cheaper to measure by satellites, the satellites can very easily collect these 510 million data grid points. So that satellite measurement is about the only way you could get anywhere near the Shannon-Nyquist sampling requirements. And it's given the satellites measure looking down at the Earth, all they can see is the top of the atmosphere, which is where the infrared heat is radiated from, because the atmosphere is opaque in the infrared, in the far infrared. So, given that we have a new definition, it means no proven positive top of atmosphere Earth's energy imbalance, then means no global warming. You're stuck with that. Okay, how accurately do you need to measure it? It was never publicly released, but it was tacitly agreed that real scientists would require plus or minus 0.1 watt per square meter. I'll show you what all that means in a minute. Let me give you a little bit of scientific jargon. Energy is measured in joules using MKS units. Power is an energy flow rate. It's measured in watts. Okay, it's in joules per second. So it's a for the calculus not impaired, it's a time derivative. Okay, so it's the power flux is the average energy flow per unit of the flux is per unit of the Earth's, by convention, total surface area. And it's measured in watts per square meter. It's the daily average, and so that includes the nighttime too, when there's no sunlight shining. So you only get half as much. Okay, there's also some IPCC jargon just put there to confuse people as far as I can tell. They call sunlight, everybody knows what sunlight is. They call that shortwave radiation or SW radiation, just so you'll be confused. They call far infrared thermal heat radiation. We all know about radiant heat. Some of us have it in our houses to keep us warm. They call that LW radiation. The Earth's energy imbalance really means the Earth's power flux imbalance. They were calculus challenged, I guess. One is a rate, one is an actual value of energy. Okay, so EEI is actually the power flux, and it's measured in watts per square meter. And remember, it is measured at the top of atmosphere. And so this specifies that it should be top of atmosphere EEI. Unfortunately, they left out definition of what is the actual altitude that we're talking about. And they kind of sneak in here, well, ocean heat content, well, yeah, that's actually measured at the bottom of the atmosphere. We'll ignore that little detail. So they have the ocean heat content anomalies masquerading as top of atmosphere EEI. Another one, this is Martin Wild at Zurich University and ETH University. He redefines the word bias as meaning the difference between the measured value and the theoretical value. So, as in, don't bias my opinion by confusing me with clearly observed facts. Okay, so what is this fancy new thing, EEI, or Earth's energy imbalance? It means simply more power coming into the Earth than is going out. Okay, the difference between what's coming in and going out is the imbalance. Okay, and this all starts from a very simple conservation of energy, and it's actually from a little bit mathematically inclined. It comes from flow through what's called a Gaussian surface in the continuity equation. Suppose you have a closed surface, like a sphere. It's got an inside distinct from an outside. Okay, and you have flow of some quantity anywhere and everywhere through that sphere from the outside to the inside and from the inside back to the outside. If you have the constant continuity equation says if you have more stuff flowing in than flowing out, you will get a buildup of stuff. Pretty simple and straightforward. Second piece of physics that's required is Boltzmann's relation. Says that if the accumulated energy that's stored inside this volume is thermal heat energy, then the temperature rises. So here we have now linked in global warming. And the proportionality constant is Boltzmann's constant. 1.38 joules per degree centigrade or degree Kelvin. So conservation of energy and Boltzmann's relation all say if we have more power flowing in than flowing out, then we have a buildup of heat energy and we have global warming. Okay, so by convention, this is top of the atmosphere. And the advantage of doing it there is it's very simple. There are really only three energy flows. The bad news is there is no Gaussian surface appropriate for the bottom of the atmosphere. They kind of ignore this fact. Ramanathan and NCAR in 1987 published the first power flow diagram. This shows essentially that flow I was talking about. Here, we have sunlight coming in, we have reflected sunlight going out, we have radiant heat going out. There are really only three power flows across that surface you need to consider. And you have this Gaussian surface sphere surrounding the Earth. Okay, so once we've reduced it to three numbers, then the audit is easy. It's just a four-line audit. We subtract the power going out, the two components of it, from the power coming in, and we get the Earth energy imbalance. And the other important thing that an experimentalist needs to know is, well, if we suppose each one of these has a measurement error, how does this reflect in the measurement of the EEI value? Well, an immediate cross-check is that you can't do any better than any one of them. Every one of them, the final error or estimated uncertainty level is always greater than any one of them of the components. Okay, so if you see where that's not true, you should immediately be suspect that somebody's cheating. So the other question is, how far does it have to be above zero for you to claim global warming? Well, some factor n times the error I have a whole appendix of values. In physics, it's like 5. They were getting by with 1.5, then tried to do a little bit better between AR5 and AR6. How is it reported? Well, I showed you Ramanathan's earlier diagram. This is the power flow diagram from the 6th assessment report, AR6, 2021. It shows the three numbers. Here are power coming in, reflected sunlight, thermal energy going out. And here they show the power flow going into the ocean here. They are very sloppy about what all is going on here in between, the altitudes of all these processes. This is really, really bad science. Now, they also, if you notice, we have here, these are whole numbers, integers, okay? The sum of those ends up here a fraction of an integer. Something's wrong with that arithmetic. Okay. Move on. Unfortunately, all of these numbers are cheating. Normally, you would expect the numbers presented on a so-called scientific report, like the AR6 assessment report, to be actual measured values with measurement errors on them. That is a bad assumption. If you carefully read the text and you compare the numbers in the text of the articles to the numbers on the diagram, they're very, very different. The report, apparently these numbers just simply get changed from leaving the desks of the scientists to the publication by some editor or politically motivated. Okay, what they actually say they're doing is they're not really reporting. If you look at carefully into the text, they say, well, we really didn't report the measurements. We reported our best guess. There's no scientific definition of our best guess. Okay, so the so-called data, also you will find, if you look more closely, has been fraudulently, totally fudged. It's been recalibrated or it has been adjusted. Roland Connolly yesterday was talking about adjustments made. That is bad science. You're not allowed to do that. If you have glitches like that in the data that he was showing, you simply throw it out and say, well, something's wrong with it. I don't know what's wrong with it. I don't have the time to find out. I'll just correct the errors in the experiment and measure it again. Okay, so how do you actually measure this power imbalance that I'm talking about? Well, the easiest way is by satellites, and that was the original plan by Ramanathan and Stevens et al. In 1987. And their data came from the EIKE, Earth Radiation Budget Experiment. The first reported work was by Stevens et al. In 1981, and he got a positive energy imbalance, but huge error bars. Ramanathan didn't even give error bars, and he just called it zero. Okay, the 16 years after Ramanathan and 22 years after Stevens et al. 1980, we still didn't have any new data, and the National Academy, this is back when the National Academy consisted of real scientists, commented, the observations do not meet quality standards. That's their auditors, the extent of their audit. Okay, so 31 years after Stevens et al., and with 10 years of observation from the Terra and Aqua satellites, nearly all of the principal investigators finally admitted, gee, the satellite data are flawed. They're totally incapable of measuring this energy imbalance. And certainly not to the plus or minus 0.1 watt per square meter. These are the CYA comments from some of them. Loeb says, a limitation of the satellite data is their inability to provide an absolute measure of the net top of atmosphere radiation imbalance to the required accuracy level. He admits it right there. He was in charge of the program. Stevens admits, combined uncertainty is of the satellites plus or minus 4 watts. Somewhat later, Johnson, Lyman, and Loeb say, well, the Sarah's random errors were plus or minus 0.1. That met their tacit standard. Then Loeb et al. In 2018 go on to say, well, still impossible to do it. You'll notice, okay, they are saying, well, we have error here of plus or minus 4. Where's it? So we have a huge difference. The random errors, they actually were good enough, but it reveals that we had a flaw, a systematic error that they could not correct. Okay, so first off, what went right? the fact that they could measure 2.1 random errors. Okay, why is that difficult? The big problem is you're measuring the very small difference between two very big numbers. So any fractional error on the big numbers ends up swamping the, any significant error there ends up swamping the final difference that you're looking for. And even things like simple round-off error, as I was showing earlier, can simply swamp the error. So extreme measurement accuracy is required. But to their credit, this is the good news, they actually were successful in getting that accomplished. So where did this oh shit moment come from? That what they measured was a positive energy imbalance of 6.5 watts per square meter. That was ridiculously high. Nobody would believe that, and they knew it was bad. It is not warming that fast. So there was a huge flaw in these satellites, which everybody spent a lot of money on. We got to cover up this our error. Missing data were the problem, and I'll go into detail about what there are. An important part of the unsampled data was that the satellites were literally totally blind to what's called sun glare. You all know what that is. You can see it reflecting off the water's surface. Okay, Hansen in 2011 even admits that, yeah, we didn't do the angular averaging correctly. And that we had this imbalance of 6.5 watts per square meter. Okay, a little bit, and he says, because this result is implausible, instrumentation calibration factors were introduced to reduce the imbalance suggested by climate models. So right there, he's saying we're going to fudge the data, and we'll fudge it with help of load. Okay, so let me go on to what is that flaw. Okay, there are two kinds of reflections. If you shine a flashlight beam at a silvered mirror, it'll come out in a very narrow beam. It'll be reflected. That's a specular reflection. The second method is you shine at a piece of white paper, it will be reflected pretty much in every direction. The reflected light beam, okay, the specular reflection clearly depends, the ingoing ray determines the direction of the outgoing ray from the reflection. Okay? One of the things they hadn't noticed, but it's in Born and Wolf's book on optics, that if you have a reflection from a dielectric surface, you can see this faint reflection into a glass window if you look at it. If you look at it at grazing incidence, like if you look at it perpendicular, it's very small. You only faintly comb your hair in a window. But if you look at it at grazing incidence, it's extremely strong, and as you approach grazing incidence, it goes to become a perfect reflector. So with the sun is, say, no higher than 15 to 20 degrees low on the horizon, morning or late afternoon, early evening, you will see very large reflected sunlight off of the ocean. So the oceans are 71% of the Earth. So the ocean surface is like a slightly wrinkled, partially reflecting mirror, and it provides very bright directional reflected sun glare. The bright reflected light is polarized, and it's the reason that Polaroid sunglasses were invented. Okay, the reflection, because of the wrinkles, diffuses out the reflected beam into a narrow cone, 15 degrees or so wide, typical slope of the ocean waves. Okay, but it's random because it doesn't occur on very cloudy or overcast days. So the satellite, if it's trying to detect that, needs to have a field of view wide enough that it can see that. Terra and Aqua did not. Okay, if you look at a body of water, a sun low on the horizon, what do you see? You see this big bright stripe of sunlight reflected from the surface. It's always pointed in the direction of the azimuth of the sun. Okay, Terra and Aqua did not see this because instead of having a wide field of view, they did a line scan imaging. Okay, so you got to average over all these various angles. They said, well, let's just assume it's cylindrically symmetric. It's clearly not. Okay, what is needed, okay, Griggs did this correctly in 1968, trying to measure the albedo of the Earth's reflectivity of stratus clouds on the Pacific Ocean using a pyrometer. You had one looking up, one looking down. Okay, what is a pyrometer? Okay, there's no image. It does not attempt to make an image. It just collects energy. Okay, it's got a totally wide angle field of view, totally panoramic view. Okay, and you need to go all the way out from in a satellite. You need to go out all the way out to the horizon to see this light. Okay, instead, Terra and Aqua used a MODIS imaging multi-wavelength spectrometers. They were trying to do too much more than what they could do, but they wanted to measure more than just LW and SW radiation. They wanted to measure 16 LW channels and 19 shortwave. Unfortunately, they burned up all of that and wasted it in not measuring the full panoramic view. Okay, they had 14 orbits a day, and what they did was they did a line scan where they were looking straight down, and they had a fan-shaped beam doing a line scan. Now, remember, the stripe of the reflected sunlight comes from the direction of the sun. They were flying in north-south orbits. They only looked exactly east and west. The sun is never exactly east and west, except briefly 1 or 2 days a year, no matter where you're standing. And if you're in northern or southern latitudes, it's never exactly east-west. So you never can see it. Okay, so and since it's variable, you can't even simulate it. Hansen apparently was asked, see, could he simulate it? Well, we don't know what the cloud cover was. So there's no way we could simulate it. And so the net result is, if you underestimate the reflected sunlight, you overestimate the reflected EEI. Okay, so see, I think so what did they end up doing? Let me first give you some very careful definitions of what I'm going to say. Like I said, it's not easy accusing your fellow scientists of cheating. They define the word fudge, constrainment, and scientific misconduct. Okay, here's the definition of scientific misconduct. If the experimental data results don't match the preferred theory, change the measured data values to match the theory. That's fudging the data. In honest science, it's the other way around. Given you have a mismatch, you change the theory to match the experimental data. And you throw out all of the bad data. You don't homogenize like Roland Connolly was talking about yesterday. You just simply throw it all out. Fix your experiment and repeat the experiment correctly. Okay, so, and fudging the data is generally agreed in the scientific community. That is very serious scientific misconduct. Now, in order to do this, we need to change the word, the English language a bit, and so we can add a few new changes. Loeb et al. Introduced the word constrainment. It's not in any dictionary. It's not Webster's or Oxford. Okay. The word constrain means to force or produce in an unnatural, restrained manner, to force or to compel out in opposition to nature, to put together clumsily or dishonestly, to patch or fake, or to talk nonsense. That's exactly, okay. That's exactly what Loeb et al. Did. They said they were going to be, they were applying, this is a direct quote, applying an objective constrainment algorithm to adjust. This is the magic word they use. They adjust the data, adjust the top SW and LW TOA fluxes, whatever those are, to within their ranges of uncertainty. No, you're not allowed to move them around. To remove the inconsistency, i.e. to make the data agree with each other and to the theory. To remove the inconsistency between the average global net TOA flux and uncertainty between average heat storage and Earth's atmospheric system. That's fudging the data. I'm sorry. That's one of our scientific no-nos. Okay, so 5 out of the 6 forms of cheating are what I use this objective constrainment algorithm that Loeb invented. It's not allowed normally in science. My favorite way of analyzing it is in a book called by Bevington of how you analyze data. This is totally out of the question. Hansen et al. And Loeb et al. Admit to fudging the data to cover up the design flaws. They even admit there were design flaws, and they admit to covering them up. Okay, Loeb et al. In 2018 admit to changing the measured data values to match the preferred theory, admit to fabricating data to fill in gaps. If you don't have any data because, well, the experiment stopped working for a while, we're just making it up. That's also a no-no. Okay, worse yet, number 4 is what we saw there, is when the data change, when they leave the desks of the scientists and they end up in publication, some editor or some politician or somewhere just doesn't like those numbers because they don't agree with what the politician wanted, so they just simply change the numbers. That's what you see in the IPCC reports. Okay, so Hansen quotes that reveals the cover-up. Because this result is implausible, instrumentation calibration factors were introduced to reduce the imbalance to the imbalance suggested by climate models. He has his preferred model of 0.85, which was Loeb et al. Okay, so scientific misconduct number 1 is these guys just simply even proposing to change and fudge the data at all. Okay, it fits exactly the word, I use the word fudge here. So Hansen proposes an alternative, potentially accurate approach to measure is to use instead ocean heat content data. He's been arguing that has been his pet project for years. Okay, number 2. Let's get on to how does the fudging of the data for the ocean heat content. Okay, that was done by combining data from the XBT and Argo measurements. Lyman et al. Did that in 2010. And they came up with this magical number that EEI is positive 0.64 plus or minus 1,1. Although, now, as I mentioned before, this was not top of the atmosphere, this is bottom of the atmosphere. And there were other reporters, for example, Levitas et al. Did it, and they got very different results. Okay, and all of the other results showed EEI was 0. So then number 3 comes when they forced a collaboration. We had a forced collaboration with Stevens et al. In 2012, and Loeb et al. And Lyman et al. Then forced Stevens et al. To publish it in this very important seminal report that they noticed they toned down. They went from 0.64. I lost my pointer. 0.64 to 0.6 plus or minus 0.4. It's a much weaker result. That their collaborators, Stevens et al. And Wild et al. Were also in there. Now, Stevens and LeCoullier couldn't handle this. They were not into cheating, were not into fudging. So, 3 years later, they both disavowed those results, and they admitted to scientific misconduct, and they retracted those values. So they themselves called this whole result a fudge. Okay, in a minute I will show you their retractions and what the Stevens et al. Report actually said. Stevens reported this 0.6 plus or minus 0.4 on 2 different power flow diagrams, which all had fudged arithmetic that didn't add on them. Does that work now? Nope, not yet. Okay, so what did Hansen et al. Do? So he suggested, well, we got to replace it with the flawed ocean heat content data. And they show that they claimed the Argo floats had sufficient time and accuracy. And they admitted that you need to do this very carefully, very precisely. And they admitted, yes, there are other analyses of these floats that get very different answers by a factor of 2. Now, that's okay. Factor of 2 error, Al Gore calls that consensus. So hey, have I gotten to? I lost my Stevens et al. No, I'll get to those in a minute. Okay. So they went on. Okay. Next thing is the flawed. They've suggested the use of flawed temperature anomaly data. Okay, where are we? Okay. Ocean heat content data were used, and that's not really what they measured. What they really measured was ocean temperature data. Okay, this was also measured at the bottom of the atmosphere, not the top of the atmosphere. There's no Gaussian surface, no power flow, there's no conservation of energy argument. Okay, you got a lot of flows in and out of every one of these oceans. There's no automatic way you can use the same nice, simple, clean system that the satellite data. Okay, you need to do two conversions. Remember, we needed to convert a rate, and we needed to convert from energy to a power flow rate, and we needed to also convert temperature to data to energy content. Okay. So they had a multiplicity of different areas, different oceans. Levitas et al. Had like 12 different plots he did of these. Lyman in 2010 only had one, which was just some covered up average of all of them. Didn't say how he averaged. Okay, somehow you got to combine all these ocean averages. Oops. Okay. Ocean temperature measurements are only recorded as temperature anomalies. Remember, I was commenting about anomalies. Okay, we have. First, I need to point out that there are two different ways of doing this. There are two different programs. There are the Argo buoys that Jonathan talked about, and there's the XBT buoys. These were all. It's an old military program that was trying to map out the thermocline for submarine warfare use. They just were throwing buckets over the side, pull them up, and sticking a thermometer in them. They had no idea how deep the water came from. They were only recorded as temperature anomalies. They forgot what was the reference value they started with. They forgot what was subtracted off. Different oceans had different coverage levels. Okay. The important thing about the Argo data is that almost all of the Southern Ocean were measured using Argos. So they had the Argo data and XBT data had a different composition of Southern Ocean, but they decided to combine them all. Okay, so they are also grossly undersampled, and they don't account for the surface currents, the Enzo currents, the El Nino and La Nina. So originally Hansen suggested we use only Argo, but in fact, what they ended up, Lyman et al. Just ended up combining. And you'll see that there are three important data periods. There was an early data from 93 to 99 that was all XBT. In between is a mix of the two, and 2004 2009 was Argo only. Levitas et al. Looked earlier for the period 1950. This is a 45 years long period, and I've done the same trick here that I did with the NOAA data. That I plotted it twice, once backwards and once forwards. If you can see any trend, upward trend from left to right, and tell me which one is increasing in time. You do see a lot of oscillations. Those are presumably all the various Enzo data. Okay, so Lyman et al. Have to do a conversion of the bottom of the atmosphere temperature data to top of the atmosphere. Okay, so we have to combine all these various teams measurements. We have to put them as a function of time, convert ocean heat content from temperatures using Boltzmann relation backwards. We have to convert bottom of the atmosphere somehow to ocean history record versus time. You need to measure a derivative. Measuring time derivatives is a bitch because any fluctuations in high frequency data are always amplified on this. And even Hansen recognized that was a difficult problem. And they've left out all the arguments of how you get from bottom of the atmosphere to top of the atmosphere. So these are the various different cases so naturally Hansen gets to select. Hansen picks the one with the highest value. Well, here's what Lyman et al. Did. The left period, first period, is XBT only. And the right-hand, period 3, is Argo only. And remember, Argo has a lot more Southern Ocean content. And what they did was in between, they just got fewer and fewer Argo buoys and more, fewer and fewer XBT data points and more Argo data points. So what you're seeing here is more and more Southern Ocean data with a different offset correction. They even admit they had to adjust these values upwards by 7 watts per, by 7 times 10 to the 22 joules. That's pretty much half of the full scale of the vertical dimension here. Okay, so what's that? Okay, I will hurry through. Okay, sorry. Okay. So there's an alternative hypothesis you can use, is that both of these curves are flat, and they just simply rejected that. They admitted that they knew that this was true. They had the bottom line is their CYA comment, but they knew all of this, but they just still simply selected the one that gave the large value. Loeb et al. Went on to massage these data, and they got combined into the Stevens et al. Model. Okay, so unfortunately, so this came out. Here's their power flow diagrams for Stevens et al. You'll notice there's bad arithmetic here, and then comment that Stevens and LeCoullier publicly retracted this. They did this here. Okay, LeCoullier first put in a very mild retraction and got 0 imbalance. Okay, here's his power flow diagram. Okay, Stevens and LeCoullier, here is where they really admit to scientific misconduct. They show independently OHC, the ocean heat con data and the satellite data, and they admit that there's no reason to prefer one over the other. But then they admit that their best estimate is 0 power imbalance. But then in the abstract, they still get this 0.6 plus or minus 0.4. Where'd that come from? That appears some editor somewhere just simply rewrote their abstract and put in that number because that's what the politicians wanted. That's gross scientific misconduct number 4. And you will see, okay, well, I have to skip through since I run out of time here. From AR5 to AR6, things get much dirtier and much worse. Okay, let me see. They wanted to essentially use the CMIP5 simulations and use those to improve the analysis, do this all with computer simulation. Sorry, terrible run on my time here. Okay. So let me go on. Okay. So they decided, well, we can fix this just by computer simulating everything. Okay, and so Hansen all admits, well, there are discrepancies in the computer between the observations and the simulations, but even if they're in error, we still should use their predictions. Okay, so how big are those errors? The typical range of errors from 43 different calculations, different models, has 48 watts full-scale error. This is what is called consensus. These are 20 different laboratories around the world produce these results. And they still call this consensus. These are the typical errors in some of the values. That's it? Okay. So here's how bad the CMIP5 is. Let me move on. Okay. Here's how bad they're calculating. They can't even simulate the albedo. The one that I really need to get to is Wild et al. This one I can't leave out. This here they had two different cases, and in order to fudge it, they calculated for land and for sea separately, and they said that for some reason, in order to make this work, we have to have the sun shine 22 watts per square meter more brightly on the ocean. How do on the land? How do the sunlight photons know how to do that to divert course? Impossible. Those are gross fudges. Okay, it gets all covered up when they combine them. So that's Wild et al. This then propagates through to AR Wild 19 to AR6. This Loeb et al. Then fudge the data from ocean heat content to get the final number for the imbalance. Okay, and now let me skip to here's the final audit list, and then I'll get to the conclusions. Okay, these are the various, all of these, the right-hand column is all the fudge data. The next to the last column, the fifth column, is the actual correctly done arithmetic. This is just, all of this stuff has just been totally fudged. This is gross scientific misconduct. Okay. Okay. Now, it turns out if you correct those, the Wild et al. Fudges, and you put them in, and you run through from AR5, Wild et al. 2015, 2019 to AR6, there is no heat imbalance. The heat imbalance that observed is all fudged. So we leave out the methods of the fudge and then just jump to the conclusions. Okay, there's no positive energy imbalance that's been observed. There is no proven global warming. There is no observed frequency of extreme weather events. There is no proven climate change crisis. There's no quantitative consensus among all the various climate, despite what Al Gore, this factor of 2 disagreement, that's consensus. The world is wasting trillions of dollars in vain attempts to limit fossil fuels. If it ain't broke, don't fix it. I will quit. Thank you. Thank you.